Imagine if human could do the same. Reset our bodies, regenerate our cells, and avoid aging altogether. Cutting DNA at specific spots so that scientists can add, remove, or change parts of our genetic material. Telomeres protect our DNA from damage during cell division. But as they get shorter, this protection weakens, leading to cell death. It may have the potential as an anti-aging drug. Some experts believe by 2045 we might be able to upload our minds to computers, potentially achieving a form of digital immortality. Some animals don't seem to age like we do, and this has fascinated scientists for years. The jellyfish can reverse its aging process and return to earlier stage of life, essentially making itself younger again and again. This process is known as transdifferentiation, allows it to start its life cycle over, making it potentially biologically immortal. Hydra, tiny water creatures, have the ability to continuously regenerate their cells, which means they don't age in typical way. They can replace damaged cell indefinitely, which prevents the usual signs of aging. Planarian worms also can regenerate almost any part of their body endlessly. This incredible ability to regenerate has made them an important subject of aging research. By studying these animals, scientists hope to discover the secret of slowing or even reversing aging in humans, according to some research. So these creatures shows us the nature has already found ways to defy aging, and science is working to see how we can use these biological tricks to extend human life. Imagine if human could do the same. Reset our bodies, regenerate our cells, and avoid aging altogether. Inspired by these fascinating creatures, scientists today are making incredible progress in understanding and potentially extending human life. Researchers are exploring many different approaches to achieve this, and some of the most promising involve targeting building blocks of our biology. One major focus of life extension research is fighting the effect of aging at cellular level. Scientists are working on techniques like senolytics, which aim to remove harmful zombie cells, old cells that stop dividing but won't die off, that build up in our bodies and contribute to aging. Studies in mice have shown that removing these cells can extend their lifespan by 17 to 42%, depending on several factors including sex, diet, and genetic background. By getting rid of these cells, scientists hope to keep tissues healthier for longer. Another key tool in this research is CRISPR, a powerful gene editing technology that allows scientists to make precise changes in our DNA. CRISPR stands for Cluster Regulatory Interspaced Short Palindromic Repeats. This technology has received support from major organizations, including Google-backed companies, which are investing in the potential to treat genetic disease and extend human health. It works by using a typical enzyme called Cas9, which acts like a pair of molecular scissors, cutting DNA at specific spots so that scientists can add, remove, or change parts of our genetic material. Recently, the first CRISPR gene editing medicine called Casgevy was approved in United States FDA. Casgevy treats sickle cell disease, which causes mutant hemoglobin to turn healthy red blood cells into harder cushion shape that can lump together and cause extreme pain and oxygen deprivation. Before CRISPR, the most effective treatment was a bone marrow transplant, which required finding a matching donor. Now with CRISPR, it's possible to edit the person's own cell to produce healthy hemoglobin. This development shows the immense potential of CRISPR not only for treating disease but also tackling age-related conditions. CRISPR has the potential to treat genes associated with aging and age-related diseases such as cardiovascular diseases, Alzheimer's disease, Parkinson's disease, type 2 diabetes, and certain cancers, offering a promising route to slow or reverse aging. With CRISPR, scientists can target and fix the genes that are linked to aging, potentially helping us live longer and healthier lives. Telomeres are another focus. These protective caps at the end of our chromosome that get shorter at each time a cell divides, similar to how the caps at the end of shoelace protect them from wearing out. Telomeres protect our DNA from damage during cell division. But as they get shorter, this protection weakens, leading to cell death. As telomeres get shorter, the cell eventually loses its ability to divide and dies. Scientists are exploring ways to extend telomeres or activate an enzyme called telomerase, which helps rebuild these gaps to slow down or even reverse aging. Some medications are also being studied and help extend human lifespan. One such drug is Rapamycin, which has shown promise in delaying aging in animal models. It works by inhibiting a protein called mTOR, which plays a role in cell growth and metabolism. Rapamycin is currently used in humans as an immunosuppressant for organ transplant patients. It may have the potential as an anti-aging drug. The cost of Rapamycin varies depending on the dosage and the region, but it generally ranges in between $100 and $200 per month. However, it comes with side effects such as increased risk of infections, digestive issues, and mouth sores, which makes it unsuitable for everyone. It is primarily prescribed for transplant patients and only be considered for anti-aging use under strict medical supervision. Another promising drug is metformin, commonly used to treat type 2 diabetes. Studies suggest it may help reduce inflammation and improve overall health in aging individuals. Metformin is much cheaper, costing around $4 to $10 per month, but it may cause gastrointestinal upset in some people. Researchers are still investigating the long-term effect of these drugs on lifespan. New technologies are also being developed to help us live longer. Cryonics is one such approach, freezing bodies at very low temperatures, often around negative 196 degrees Celsius, with the hope that future technology will be advanced enough to revive them. Companies like Alker are already offering cryopreservation services, with over 400 individuals currently cryopreserved. Some experts believe by 2045 we might be able to upload our minds to computers, potentially achieving a form of digital immortality. While these ideas may sound like science fiction, they show how far we are willing to go to avoid death. From freezing our bodies to digitizing our consciousness, we are pushing the boundaries of what it means to be alive. Transhumanism is about technology to enhance human abilities to push beyond our biological limits. This movement includes a range of ideas from improving physical and mental performance to potentially achieving immortality. Some people want to use these technologies to stop aging through biological modifications, while others dream of uploading their minds to computers to achieve a form of digital existence. For example, efforts are being made to develop brain-machine interface that could one day store human thoughts and memories digitally. Recent research shows that brain reading implants have been used to turn thoughts into speech, with impressive results in participants with conditions like ALS. It refers to amyotrophic lateral sclerosis, which is a progressive neurodegenerative disease that affects nerve cells in brains and spinal cord. It's also commonly known as Lou Gehrig's disease. ALS leads to the loss of muscle control, making it difficult for individuals to speak, swallow, and eventually breathe. It is one of the conditions where brain-machine interface have been tested to help patients communicate through thoughts, as the disease can leave them unable to move or speak. This device can interpret the intent behind certain neural signals, allowing people to communicate through computer voice or written language, offering a potential step towards storing thoughts digitally. This might sound far-fetched, but progress is happening. Researchers are already extending the lives of animals like worms and mice at the first step. If these experiments are successful, they could lead to breakthrough for humans. But if we manage to live longer, we need to think about what it would mean for our relationship, society, and mental well-being. If we could live forever, it would raise many ethical questions. Who would access these life-extending technologies? If only rich could afford it, the gap between rich and poor would get even bigger. Overpopulation is another issue. How do we manage our limited resources if people stop dying? And would living forever make life less special? Would we still be motivated to make a difference, take risks, or fall in love if we had unlimited time? These are important questions to consider as we explore the idea of immortality. Even though immortality is still far off, maybe that's okay. Knowing that our time is limited helps us live with purpose. Accepting death can help us focus on what really matters: our relationship, passion, and the positive impact that we leave behind. It's also important to make the most of the time that we have. Living a meaningful life might be a real key to leaving a lasting legacy.